Hello, everyone. My name is Rupeng An. I'm a professor at New York University. Today, I would like to show you how you can use the recently developed OpenAI Swarm platform to orchestrate multiple agents. So previously, most of the agents created by large language models can only interact with a human being. For example, the famous OpenAI assistant that can have a genuine conversation with client who is a human being. However, that assistant approach is appropriate when you have a relatively simple, straightforward chatbot type of question that assistant could help with. But as the tasks become more complicated, it might be useful to adopt several agents that can, for example, debate or discuss a solution from different perspectives or from different expertise. So this demand give rise to um, the requirement for orchestrate complex discussion interaction between multiple agents representing different perspectives or different techniques. Um, so how to orchestrate multiple agents is a challenging problem that a few platforms such as Crew AI, um, the LangGraph from LangChain, or Auto Gen has tried to implement orchestration for multiple agents, but they are usually associated with a deeper learning curve. However, about 3 weeks ago, OpenAI published a Swarm platform, which provide a very simple API that allow you to create agent and agent also hand off call functions and also hand off to other agents so that they can coordinate to solve a problem. So today I'm going to show you how to use the OpenAI Swarm for a few different tasks. So let's get started. First, if you want to learn more about the OpenAI Swarm, you are more than welcome to take the official documentation. And there's also a very good article that you can read through Medium. Um, and we adopted some examples from both the official documentation as well as the Medium article together with our own implementation as well. So if you want to install Swarm, you can pip install here. And you can take a look at the show notes that we provide the entire IP1B file for you to follow. So we need to import modules. And here, besides the Swarm module, we also include a few functions from LangChain, which could be helpful later on. And also imported Pydantic, which will help with formatting the large language model outputs. And I saved my OpenAI API key to the environment variable so that I can load it and use the GPT models through OpenAI. So because the Swarm is developed by OpenAI, currently it only supports OpenAI models, so you do need to have an OpenAI API key to be able to use the Swarm. Okay, so first let's take a look at the basic example of using Swarm to orchestrate multi-agents. So I first create a Swarm client here. Sorry, we need to run from the beginning. So I create a Swarm client here, and then I define a function to allow the current agent to hand off to agent B. So because I start with agent A, and agent A is going to be able to call this function so that it can hand off to agent B. Handoff is a specific term defined by Swarm so that it make it easy for one agent to pass the conversation or request to another agent. So the function is very simple. It's just to return agent B. And then let's define agent A and agent B using the agent function from Swarm. And you can give agent A a name. We call it agent A. And you can also provide instruction to agent A. So this instruction is only specific to agent A. It works like a system's message to agent A to guide agent A's behavior. And optionally, you can also provide functions or tools that agent A can use. And that function is basically transferred to agent B. And then we create another agent, agent B. We give name agent B, and we give the instruction only talk like a 5-year-old. And notice that agent B is not associated with a function, so that agent B will not be able to pass the request to agent A. And also notice that we use a list to include the transfer to agent B function. It means that actually we can provide multiple functions to the same agent. But here we only have one. So let's create these two agents, agent A and agent B. And then we will be able to run the client. So we are going to run the Swarm client use.run. And we start with agent A. So agent equals agent A to get started with. And then we also provide initial message to agent. There is a an error here. So the message role is user, and content here I say no, I want to talk to agent B. So if I get this as the content, so when this message passed to agent A is as autonomous agent is going to think, well, since this request is the client want to talk to agent B, so I should pass it to agent B. And then let's see how that play out by print the response message and see whether first let's see what is the message, the response message, and also we'd like to see what is the current agent name. So if the passage is successful, we should see agent B as the current agent because when agent A sees the content, it should pass it to agent B. So let's take a look. And here is the return message. I sent you to agent B, and then you see that you do have the agent B. You can run a separate one, and so this is another response from agent B. I can't make phone calls or do stuff with agent, but I can chat with you. Let's talk about fun things like cartoon or superheroes. This does look like the message created by a 5-year-old. And you do see that now the current agent name is agent B. So let's see whether no agent A is truly autonomous. Say if I ask a question and this question does not actually call agent B, Agent A may think, well, in this time, I should actually address this question. I should not pass and hand off it to Agent B. Let's see whether that's the client behavior. So this time I provide the content. Fall comes and the trees are turning red. Could you provide me with a one sentence vivid description of the falling leaves? And let's see how the agent responds and what agent it is after this call is this client is called. So this time this is the message. The crimson leaves cascade gently from the trees, dancing through the crisp autumn air like fiery confetti celebrating the change of seasons, right? So this is very a poem-like message. And if you take a look of the agent, now it's agent A. So it means that agent A actually does not pass the handoff to agent B and directly address the question. Okay, so now we have a better understanding of the agent behavior, and now let's uh, try to leverage the power of agents to create two agents that can discuss a given topic to improve the solution. So let's take a look of how this can be done. Again, we initialize the swarm client, and then we define two agents for the discussion. Agent A is we name it market expert. And the instruction I given is revise the survey question further to make it more appropriate for the target customers. Provide the revised survey question with a single sentence justification. And then I create another agent represent a survey expert. And I give the instruction, revise the survey question further to make it scientifically sound and rigorous, and also provide the revised survey question with a single sentence justification. And then I can build a function to represent a discussion system. And this function calls for agent A, agent B, and calls for a topic. And also, you can specify the number of iterations. Because if you don't specify iterations, no, basically the conversation can go on indefinitely. And then here, I create a message. The messages is a list that has the role of user and content as a topic. And then I specify the current agent to be agent A. So agent A is going to get start first. And then I print out the discussion topic. And now I create a simple for loop. And you can specify the number of discussion iterations here. So in the for loop, I will run the current agent with the latest messages. So response equals client run, agent equals current agent, and messages equal to current message. And then I can print the response from the current agent. So I print the agent name together with the response. And after that, I can append the response from the agent to the message, so that when the next when the conversation is handed off to the next agent would have the conversation from the previous agent, and then we can iterate this. So we'll say current agent equals agent B if current agent equals agent A, or else would be agent A. So in this case, they are going to alternate in their response. And then I provide the discussion topic, the survey question. On a scale of 1 to 10, how likely are you to recommend our product to a friend or colleagues? So basically, these two agent, one representing a market expert, the other representing a survey expert, are going to discuss this topic and try to refine the survey question. and I set the iteration to be 4 in order not to run this too long. So let's try this. And you see that now it's done. This is the original research topic, and the first uh, the market expert revised the survey question to, based on your experience with our product, how likely are you to recommend it to someone you know? And then it also provides the justification. And then the survey expert further revised the survey question to, considering your recent usage, how would you rate your likelihood of recommending a product to a friend or colleague on a scale from 1, very unlikely, to 10, extremely likely? Okay. So the conversation goes on. The market expert revised again of the survey question. Uh, and finally, you have the survey expert intervened and further revise the survey question. And the final revised version is, thinking about your most recent experience with a product, how likely are you to recommend it to others on a scale from 1, not at all likely, to 10, extremely likely? So this seems to be pretty good. And now let's show you something even more exciting. That is, you can create 2 agents that can debate each other based on a topic given by a judge, and the judge decide which agent wins. Okay, so in this case, you have 3 agents, 2 agents as 2 debaters, and the third one serve as the judge. So let's see how we can implement that. Again, you initialize the swarm client. You define the 2 agents, and so I'm going to define debater A. I'll name it debater A and give the instruction, argue in favor of the provided statement, use up to 3 sentences in your speech. And debater B, instruction is argue against the provided statement, use up to 3 sentences in your speech. And now I also create a third agent who is a judge. And the instruction is listen to both sides and declare a winner with justification. And now I can develop a function to represent the debate system. The debate system call for the judge, call for debater A, debater B, the topic. You can provide a topic, which is the statement. And you can also specify how many rounds you want the debate to run. Again, I first print out the debate topic. The debate topic is added to the messages list. And then you can start running a for loop. It's going to print out the round first, and then first is debate A's turn. So I run this response A. I will say agent equals debate A, debater A, and messages equals messages. And then I'm going to print debater A's name and also debater A's response. And very importantly, make sure that you append the debater A's response to the messages so that it can be provided to agent B. So then it's debater B's turn. It takes the agent equals debater B, message equal messages, so that already taken into account debater A's response. And then I print debater B's name, debater B's response, and then I keep adding debater B's response to the messages. And then finally, when this loop is done, each debater has made their n rounds. Now we can print the judge's evaluation. And the judge's evaluation and agent equals judge, and then the messages will be the messages plus the content. Please evaluate and decide the winner, right? And then I'm going to print the judge's name and the judge's response. Now when this function is done, I just try it out with a debate topic. And the debate topic is high school students should have PE every school day. I'm going to run this topic for 3 rounds. Okay. So let's do this. This is the first round, debater A's argument, debater B's argument. Second round, debater A and debater B's argument. third round debate A and debater B's argument, and then finally the judge's evaluation and justification. I don't really want to spend much time on reading this debate. It's just for illustration. But interestingly, the judge make an evaluation and then and also pick a winner by the end. Hey, so you can have a different debate topic and try it out. It's pretty fascinating. And now let's build a more complex agent, complex client that has two agents and also supervisor. And the supervisor tries to choose the most suitable agent to run a task. So basically, the supervisor need to evaluate the user's request and then to decide upon which agent the supervisor should hand off to. Okay, so here I first define a function to report the weather, which is called get weather. The get weather is going to take an input is the city name, and then the get weather will say the weather in which city is always 30 degree Celsius, and you define another function called get air quality is also called for the city name. And if response with the air quality in that city is good with an AQI air quality index of 42. Okay, very simple functions. And then I'm going to define another function called route request. And route request is going to take the context variables. So the context variable is nothing but a dictionary that contains different key value pairs. And you can save arbitrary information from the key value pairs, but basically you can pass the context variables to both the agent as well as the client so that they can be used as additional information to supplement the client and the functions. Right? So context variable is just a dictionary that you can store additional information. So here the route request function take the context variables and is going to first extract the user message, if any, from the context variables. Okay. So in particular, in the context variable, there is a key called the last user message. So basically, it's going to, if the last user message exists, it's going to extract that and save that in the user matches variable. Otherwise, it's going to just get a empty string. And then it's going to test whether in that user message it has the string weather. If the weather exists in that string, then it's going to basically return the weather agent. If the air quality, the word air quality, the phrase air quality is in the user message, and then it's going to return the air quality agent. Otherwise, it would return, I'm sorry, I don't understand your request. Okay. So this function, as you can guess, will be used by the supervisor who is going to decide upon handoff to a specific agent. But now you can see there is a potential problem here that if the user message is not precisely weather, or if it's not precisely air and then empty space and then quality, for example, if the message instead of air quality is quality of the air, then it will not be picked up by this deterministic if-else statement. So later on, we are going to using soft coding, using large language models to improve this route request function. But for now, I think it's good. So we initiate this function, and then now we are able to create the agent, right? So first we create the weather agent. We name it the weather agent. I provide an instruction. You are weather assistant. Provide the weather information when asked. And then in the function, you provide get weather. So if this agent is called, then the agent is going to apply this function. Okay. Uh, and then the air quality agent, we name it air quality agent, and instruction is you are an air quality agent assistant. Provide the air quality information when asked, and then you provide the get air quality function as the functions of that air quality agent. And finally, you create the supervisor agent, which is going to assign handoff based on the user request to the two agents, the weather agent and air quality agent. So I name it supervisor agent. The instruction is you are a supervisor, determine whether the user request is about weather or air quality, and transfer them to the appropriate agent by calling the route request function. And finally, I provide that route request function, which now is hard-coded. Okay, I created three agents. And now in the user message, uh, I can test with the first user message, which is what's the weather like in Paris? Okay. Uh, and also I create this context variable. The context variable is just the last user message is just the user message. So basically, it's going to pull the user's message to determine which agent it should pick, the supervisor should pick. Um, and notice that in the user message is what is weather like in Paris. It has the exact word weather in it. So therefore, when the supervisor agent run, is going to run the route request function. And because weather is in the user message, so it should return the weather agent. So let's see whether that is case. Okay. So we run the client. We start with the supervisor agent, and then the message is just the user message, and then the contextual variables equals contextual variables. Notice that here, the client allow you to add an optional argument context variables, which is the dictionary that we define here. Okay, and then let's print the response. And not surprisingly, the response is the current weather in Paris is 30 degrees. And if you test the current agent, it should be the weather agent because the supervisor have hand the task off to the weather agent. Now let's try a different user message. This time I'll try how is the air quality in New York City, right? Uh, so this time the because we have exact word air uh, space quality, so therefore it should be picked up by the supervisor's function uh, route request and route and so that supervisor is going to pass it off to the air quality agent. So let's see whether that is the case. Okay. Uh, Let's run this. And then we do see that it's passed to the air quality agent so that it responds the air quality in New York City is currently good with the air quality index of 42. Okay. So that is pretty neat because it's called this function. Okay. So it is interesting that the city is automatically picked up by the agent. Although we do not hard code city, but the large language model understand that the input for this get air quality function called city and basically extract the city in this time the New York City from the user request, the user message. Okay. Okay. But then we have a problem because as we said previously, our request route function is hard-coded. So remember that it tests using an if-else statement whether or error and where error empty space quality is in the user message. However, if we slightly change the phrase, the if-else statement may not be able to pick it up. For example, here, instead of asking how is the air quality in New York City, I word it differently. I word it, how is the quality of air in New York City? So this time, if we run the same client, the client will not, the supervisor may not be able to pick it up and assign it to the air quality agent because the if-else statement is hard-coded and the string air quality is not in the user message this time. So let's try this. And see here, the response is, it seems there is an issue with transferring your request. Please try ask again later or check a reliable source for air quality information in New York City directly, right? So it means that this time the air quality agent is not passed to, and the supervisor is confused. Okay. So how to slightly revise this route request function so that it can understand the user request semantically rather than hard code it. So to do this, you can recall my previous presentation on LangChain, how to create a simple chain that can process your your input, your user input using large language model. Okay, so let's do this. Now, we are going to, the goal for us is going to create a new route request function that can semantically understand the user request and using that semantic understanding to assign agents rather than based on hard-coded if-else statement. To do this, first we want to make sure that the large language model is going to consistently output the agent name. Okay, so therefore I use the pandantic base model to create a class. It's called choose agent, and it's very simple. So basically, the output has to be an agent name. A JSON file, and it calls agent name, and the agent name should be a string variable. Right. So this is going to make sure that the format is always agent name, a string from the large language model. And then I can build a chat prompt template, which we can use. And this chat prompt template, I specify a system message, you are helpful assistant, and importantly, I specify the human message, and instruct the large language model on returning a agent name. So it says you will determine whether the user's request is about weather or air quality. If the request is about weather, you will output weather agent. If the request is about air quality, you should output air quality agent. And if the request is neither about weather nor about air quality, you'll return none. Okay. And the user's request is request. So in this case, I provide this template so that whenever user provides a request, we are going to invoke this template, and the output of this template is going to be an agent name. It would be either weather agent or air quality agent or none, and then we'll pass that to further processing by the client. Okay, so that is the idea. So we create this template, and then we can call an OpenAI model. We call the chat OpenAI model, which is going to process this template and then produce an output. Okay, and the output would be either weather agent or air quality agent or none, based on the user specific request. Okay. Now, and I use this pipe to create this very simple choose agent chain. And notice that I use the LLM dot with structure output, and I use the choose agent class as the output, so that output is always going to be formatted in the way that we specify here. Okay. And then I put a user request. The request is how is the quality of air in New York City, right? Notice that in the previous time when the request route function is hard coded, it cannot pick it up. And before we implement that in the client, let's first test this this chain to see whether it works. Okay. So I'm going to invoke this choose agent chain. I'm going to put the request here, and if the chain works, it should return the air quality agent, right? Because this question is truly about air quality, although the wording is the quality of air. Right? So let's try this. And yes, indeed, we get the agent name equals air quality agent, right? So this is great. This is a formatted output that we can trust. Right? And now we can build that into the choose agent chain into the route request function. Right? So we define a new route request. We call it route request semantic because it now can understand the user request semantically. The input is a user message, and then first we invoke the choose agent chain to process the user message, so that now the output of the results should be either air quality agent or weather agent or none, right? And then now we can test whether is there or air is there, right? We can actually even test more precisely air underscore quality underscore agent, right? But we want to leave some room there, so we just call air. If air is there, then return the air quality agent. If weather is there, return weather agent. If none is there, I would say I'm sorry, I don't understand the request. Okay. Okay, so that's create a new agent called supervisor agent semantic, and everything else remains the same. The only thing changes that now it has the function of route request semantic. Okay, so now let's do that, and now is the final time for us to test the efficacy of this semantic route request function. So the user message again is how is the quality of air in New York City? And then I still provide the context variable. I'm going to run the client, but this time the starting agent will be the supervisor agent semantic. And now let's see whether it can route, the supervisor agent semantics will be able to route to the air quality agent, so that air quality agent will call the get air quality function to produce the required the expected outcome. Okay, so we are good. Now the response is the air quality in New York City is good with an AQI air quality index of 42. Okay, so we have been successful in revising the hard-coded route request function to be able to incorporate semantic meaning from the user request. That's all for today. Thank you for watching.